Okay, so I'm doing 2.7 and 2.8, kind of all in one section, sort of, as much as possible. Okay. So I have the rest of this week to take care of that, and then we're still aiming for our test to be this coming Friday, all right? So we are here. All right, so first I'll start off with some problems in the text that require the graph. So look at problem 11, 2.7, page 148, number 11. Okay, so how do I do this? A particle starts by moving to the right along a horizontal line. The graph of its position function is shown in the figure. So here's a graph of the position function. When is the particle moving to the right, moving to the left, standing still? Draw a graph of the velocity function. Okay, let's think in terms of distance that we are away from home. So when the experiment begins, you haven't gone anywhere, obviously, so you're at 0. After 1 second, you're 3 meters to the right. Between 1 and 2 seconds, you're still 3 meters, which tells you you're standing still. Between 2 and 3 seconds, you're going from 3 meters down to 1 meter, so you're going back, which means you're moving to the left. Then it looks like your distance stays at 1, so standing still here. So you're 1 meter away, then 2 meters away, then 3 meters away, so again, you're moving to the right. Okay, so let's answer this question now. When is the particle moving to the right? Okay, now I don't have enough hands to do this, so you'll have to just listen to me, because I want to keep the book here. I can't write, I don't have enough hands to show you everything. So when is the particle moving to the right? It's basically whenever you have a positive slope. Okay, so when do I have a positive slope? Between 0 and 1, and between 4 and 6. Okay, so just jot down your notes, moving to the right, or maybe just write down right, R-I-G-H-T. So put parentheses, 0, 1, parentheses. So the open interval from 0 to 1, and also the open interval from 4 to 6. Left paren on 4, right paren on 6. And when is the graph moving to the left? That means it's a negative slope. So that would only be between 2 and 3. So moving to the left, or maybe just write down LEFT, parentheses, 2, 3, parentheses, 2, 3. And standing still means a slope of 0. So there's 2 places. So put between 1 and 2, so parentheses 1, 2, and parentheses 3, 4, all open intervals. Now, graph of the velocity function, that's going to be tricky for me to do because I'm running out of hands. I'm holding up the book and getting this. But I'll try to get that for you. Okay, so I'm making a table of velocity versus time. So between 0 and 1, what's the velocity? Well, it's meters per second. Change in y divided by change in x, delta y over delta x, right? So it's a slope, y divided by x. So between 0 and 1, the slope is 3, right? Over 1 up 3. Between 1 and 2, the slope is 0. So what I'm coming up with is a little table here. Okay, between 0 and 1, I'm running out of hands already, slope is 3. Between 1 and 2, slope is 0. Between 2 and 3, the slope is a negative 2, over 1 and down 2. So I'll put negative 2. Between 3 and 4, slope is 0, i.e. velocity is 0. And from 4 all the way to 6, it looks like the slope is 1. Velocity is 1, over 1, up 1. So between 4 and 6, the slope is 1. So let me see if I can show you these at the same time. No, I don't think I can. This is what I have for the velocity. Between 0 and 1, slope is 3. Between 1 and 2, 0. Between 2 and 3, negative 2. Between 3 and 4, 0. Between 4 and 6 is 1. Okay, and that matches what I have here. Between 0 and 1, slope is 3, i.e. velocity is 3, because velocity is delta y over delta x meters per second. Between 1 and 2, slope is 0. And then between 2 and 3, -2, 0, and 1. Okay, so now the task is to graph this thing. Okay, so this is problem number 11. So they want you to graph the velocity function now. Maybe piecewise defined. Okay, so I'm going from 0 to 6. 1, 2, 3, 4, 5, 6. -1, -2, 1, 2, 3. Okay, so to graph the velocity function, so between 0 and 1, it's up at 3. So 0 and 1. Okay, so this is time versus velocity. Between 1 and 2, it's down at 0. Okay, there it is, constantly 0. Between 2 and 3, it's down at -2. So -2 is down here. Between 3 and 4, it's back to 0. And then between 4 and 6, it's 1. So that's the graph of this funny thing, like that. And these are all open circles. Okay, because you have a quick change right at 1. So right at 1, we have no velocity. Because from the left, it's 3. From the right, is 0. I don't have a two-sided limit. So you cannot say any one velocity right at t equals 1, time equals 1. Likewise, at 2, and so on. So that's what I got for that one. And so I'll show you this again. You can review it on the video later. So I got these from the graph, and now you come up with a new graph. The new graph is time versus velocity, and that's what it looks like. Okay. Okay, next one I want to show you was 17. On page 149, section 2.7. Arrange the following numbers in increasing order and explain your reasoning. Okay, 0, g prime of -2, g prime of 0, g prime of 2, g prime of 4. When it says g prime, it's asking for the slope of the tangent line. Okay, so we're looking for the slope as we go along. Okay, so the slope at -2. Okay, so it looks like it's something like that. Right? G prime of 0 looks like I'm going down. G prime of 2, going up. G prime of 4, so right at 4, you're sort of like this. If it helps, think this is a ride, like a roller coaster ride. Okay? Right here, if you're at that point, you would say you're going up. And we're always going from left to right, by the way. Always going this way. Okay? Well, it looks like there was only one negative slope from the list. It was G prime of 0. Okay? This is the only place from the given numbers, that one, that one, that one, that one. This is the only place where you're going down between -2, 0, 2, and 4. So -2, +2, and +4, I would say I'm going up. As I'm moving this direction, okay, positive slope, negative slope, positive slope, positive slope, right? So the smallest number has to be the only negative number, which is right here. So I can't write it right now, but in increasing order, g prime of 0 would come first. So put g prime of 0 as the first number, because that's the only negative number, right? That's the only place where the graph is going down or the roller coaster is going down. The next number is 0. So this is the only negative number, then 0. Then you have 1, 2, 3 that are positive. So you're just comparing the steepness of each. Okay, so g prime of -2, so that one. And then there's 2, and there's 4. So which out of those 3 is the least steep? It looks to me like g prime of 4 is the least steep. If I were on this roller coaster ride, that one is not as steep. So the third number in the list is g prime of 4. And then I would say g prime of 2, a little bit steeper. And then g prime of negative 2 is the steepest of all. Right? You're just looking at the steepness, the slope. Okay, so to repeat, what's the proper order here? The order in increasing order is g prime of 0 is first. That's the only negative one. The second one is 0. Then you have 3 positive numbers. Okay. The next one would be g prime of 4. It's positive, but not as steep. Then steeper would be g prime of 2. And then the steepest of all would be g prime of negative 2. So that's the order of that one. Okay. All right, then I wanted to jump over and show you 27. No, sorry, not 27, 25. Sketch the graph of a function that is continuous on the domain from -5 to 5. So the graph can only go from -5 to 5. I'll show you quickly what I got. -5 to 5, that's it. And they're open parentheses, so you don't reach -5, you don't reach 5. Okay. G of 0 is 1. That's a single point. 0, 1. G of 0 is 1. G prime of 0 is 1. Slope at 0 is 1. So slope at 0, it's going up at a 45-degree angle. So I'm just drawing something like this. It goes up at a 45-degree angle. G prime of -2 equals 0. Slope at -2 equals 0. Okay, so I drew it like so. Now, they don't tell you what the y coordinate is. So the y coordinate could be, down here or down here. I do know that it seems to be going down. This time when I say down, it's moving from right to left. Okay, so I just had to just put it on the x-axis. It could be down here or here. But the main thing is the slope is 0. Okay, here the slope is 1. And then it says, limit as x approaches -5 from the right of the function is infinity. So as I approach -5 coming from the right side, I shoot up toward infinity, like that. And then the limit as x approaches 5 from the left of g of x equals 3. Okay, so I approach 5 coming from the left side, I approach the y value of 3. So here's the graph of everything that I have here. Okay, so like that, slope is 0, slope is 1, and it passes through the point 0, 1, and then it comes over here. Now that's not the only possible graph. There are actually infinitely many possible graphs, but here's a possibility. Okay, so I can't really show you both at the same time, sorry, but let's get the concept again. Okay, so it's defined only between -5 and 5, not counting -5, not counting 5. G of 0 is 1, that's a single dot. G prime of 0 is also 1. Let's see where to go. G prime of 0 is 1. That means the slope is 1 at 0. So it goes up at a 45-degree angle. G prime, derivative slope at -2 is 0. So slope right here is 0. It didn't tell me the y coordinate. So I put it on the x-axis, but it can be down here. It can be down here. And then they give us 2 limits. Okay, so limit as x approaches -5 coming from the right of g of x is infinity. So coming from this side, and I get real near -5, we shoot up toward infinity. And the limit as x approaches 5 from the left of g of x equals 3. So coming from the left, we get close to y equals 3. Okay, so that's that one. Okay, now I'm going to go back and do a lot more derivatives. So yeah, I was going to show you 15, maybe 35 down here, and some other ones. Okay. Oh, yeah, I'll talk about 21. I maybe won't do it. We'll talk about 21 quickly. Okay, if an equation of a tangent line to the curve y equals f of x at the point where a equals 2 is y equals 4x minus 5. Okay, that's the equation of the tangent line. Find f of 2 and f prime of 2. Okay, f of 2. Now, they don't even tell you what the function is, but you know the function will match the tangent line at that point of tangency. So f of 2, just plug in 2 right over here. Oh, we can do that. That's what, 3? 4 times 2 minus 5 is 3. So f of 2 is 3. F prime of 2, okay, f prime derivative means slope. So I want the slope. But what's the slope of this line? It's 4. Okay. So I guess I've given it to you without writing anything. So the answer to this one is 3. Just plug in 2. F prime of 2 means the slope. The slope is 4. Okay. All right, so more derivative calculations. Find the derivative of s equals 1 over t squared. So this is like y, this is like x. S is used quite often for distance or displacement. S and t is for time. The formula is 1 over t squared. So find a velocity at any time t equals a, then plug in 1, 2, and 3. Okay. Let me show you the derivation of that one. S equals 1 over t squared. So s prime, that's like y prime, limit as h approaches 0 of 1 over t plus h squared minus 1 over t squared all over 8. Right? Formula for derivative. F of x plus h minus f of x all over h. Only in this case, we're not using x, we're using t. But it's the same thing. Okay, then you know how I like this. If you have this weird looking fraction, if you divide by h, it's the same as multiplying by 1 over h. Right? So that's the way I'm going to work this out. Limit h approaches 0 of 1 over h. Okay, then 1 over t plus h squared minus 1 over t squared. And we have this same game. You need a common denominator. So this side needs that. This side needs that. So this side needs t squared over t squared. This side needs t plus h squared over t plus h squared. Right, so we've played that game before. All right, so equals limit h approaches 0, 1 over h. Notice, keep writing limit h approaches 0, limit h approaches 0. If you don't put it, I can take off points. Okay, you need to write mathematics correctly also. Okay, this is t squared minus, all right, so this same thing, t plus h squared. You know how to do that. That's like a plus b squared. And they're all positive. So if I put a negative in front, they're all negative, right? So I'm going to square this expression, t plus h squared, and put them all as negative. So t squared minus t squared minus 2th minus h squared. Okay? So t squared minus this thing squared minus minus minus. And there's my common denominator, t plus h squared times t squared. Usually don't bother multiplying out the bottom. You don't have to. Notice the t squareds cancel out. So on top, I have these two. And what do these two have in common? H. Perfect. It's going to cancel that h on the bottom. Okay. A lot of problems work that way. So factor out the h parentheses, negative 2t minus h. Cancel that h with that h. Notice I keep writing lim. So now I have limit h approaches 0 of negative 2t minus h all over t plus h squared times t squared. Now you can plug in 0 with no trouble, right? You could not plug in 0 at the beginning. Okay? When you're doing these derivatives, you're never going to be able to just plug in 0 because you're dividing by 0. We have to somehow get rid of that h there. Now that we got rid of the h, you plug in 0 right there and 0 right there. That gives me negative 2t minus nothing, negative 2t over. Now, if you put a 0 right there, it's t squared times another t squared, t to the 4th. So the answer for the derivative function is negative 2 over t cubed. And there we go. Okay, and yes, for those of you who happen to know the shortcut, you can use the shortcut on this to verify, but you can't just go straight to the shortcut. You have to show me all this stuff here. And again, for those of you that don't know the shortcut, don't worry about it. You'll learn it in chapter 3. Now, the rest of the problem says, what is it when t is a, 1, 2, and 3? Well, I now have a derivative formula. So I don't have to go back and do this all over again. All I have to do is just plug in. So plug in a, negative 2 over a cubed. Plug in 1, s prime of 1, negative 2 over 1 cubed, negative 2, and so on. I didn't bother to do t equals 2 or t equals 3. Just do the same thing. Plug in 2, plug in 3, and go from there. Okay. Next one I want to show you is 35. Find f prime of a. So I'll find f prime of x, and then plug in a. Square root of 1 minus 2x. Find the derivative of square root of 1 minus 2x. Once again, some of you know the shortcut. You're not allowed to use the shortcut for now. You got to do it by the limit definition. All right, so here we go. F prime of x equals limit h approaches 0, f of x plus h. So right here, like other functions, erase the x, put parentheses, x plus h. Minus f of x, the original function, radical 1 minus 2x, all over h. Okay, so again, the derivative formula, put it on your cheat sheet. It was right there, right? F prime of x, limit h approaches 0, f of x plus h minus f of x all over h. This was the start of 2.8, page 152. All right, so I clean this up. That's 1 minus 2x minus 2h. Okay. And you guys have it somewhat fortunate because, again, if we were meeting on campus, I would make you memorize the formula for the derivative. That's standard, that's par for the course. But since we're, shelter in place, we were supposed to make it somewhat easier on you guys, and that's one way to make it easier. All right, well, you've seen this theme before. Multiply by the conjugate of the numerator, rationalize the numerator, which is radical plus radical, right? So radical, just copy that. Radical, just copy that, and make it a plus. Plus, that's supposed to be a minus there. I made a mistake there. So radical 1 minus 2x minus 2h plus radical 1 minus 2x. Same thing on the bottom. Remember, what you're really doing when you put all this stuff is you're multiplying by 1. This is a fancy way of writing 1. And whenever you multiply by 1, you don't change the value of the expression, right? Okay, now I got to go back up, but look at how nice this comes. Okay, it's basically a squared minus b squared. What is this times this? Just take off the square root, right? What's this times this? Just take off the square root. So on top, I have 1 minus 2x minus 2h minus parentheses 1 minus 2x. Okay, so here we go. 1 minus 2x minus 2h, that's that times that, minus that times that is just 1 minus 2x. And notice the 1's cancel out, the negative 2x's cancel out, right? Remember, that's a minus minus. It's negative 2x plus 2x. So the numerator is negative 2h. Guess what happens to that h? Cancel with that h. Again, you're almost always looking for something like that. There's got to be that cancellation. So in the numerator, I just have negative 2. Now I can just plug in 0. So put a 0 right there for h. So negative 2 over radical 1 minus 2x plus another radical 1 minus 2x. That's 2 radical 1 minus 2x on the bottom. And then I just cancel the 2's. So final answer is negative 1 over radical 1 minus 2x. So the derivative of this is this. And yes, some of you who know the shortcut, you could do that a lot faster. Again, you have to show me all this stuff, but you can do that as a double check. Now, very strictly speaking, it asks for f prime of a, so I just plug in a. So negative 1 over radical 1 minus 2a. Okay. All right, next one I was going to show you was 2.821. So I'm jumping back and forth between 2.7 and 2.8. Like I said, it would, I want to get similar themes together. So a lot of times there'll be some derivatives, f prime of x, limit h approaches 0, f of x plus h minus f of x all over h. So I just want to do a lot of them together. So that's the reason why I'm doing that. And then there are some graphs that are better to be done together. So 2.7 has some graphs. 2.8 also has some graphs. Okay, so what's the derivative of 3x minus 8? Again, no fair. Those of you who know the shortcut, you got to show me all of this. Okay, so 2.8, problem number 21. So we have some more derivatives over here also. So what's the derivative of 3x minus 8? Again, using the definition of the derivative. Okay, so no shortcuts. All right, so limit h approaches 0, f of x plus h minus f of x all over h. Okay, so maybe I'll write this for you. This stuff is f of x plus h from the limit definition. This stuff is the f of x. Okay, so f prime of x, again, when you write this f apostrophe, you say f prime. Limit h approaches 0, f of x plus h, 3 times x plus h minus 8, minus 3x minus 8, that's the f of x, all over h. Do not plug in right now. You're never going to be able to plug in right away because you're going to divide by 0. The whole idea is to cancel out that h. All right, and this is not too bad. 3x plus 3h minus 8. Distribute the negative minus 3x plus 8, right? Minus and minus. Very conveniently, the x's cancel out. The h's cancel out. So it looks like I just have 3h over h. These cancel out. So I just have to limit as h approaches 0 of 3. And whenever you have that, it's just 3. Okay. This is easier than I think. Sometimes this throws students off. So, oh, what do I do with this right here? Limit as h approaches 0 of 3 is 3. Well, you don't care if h approaches 0 of 3. It stays 3. Okay. It's almost like saying, what happens to number 3 if today happens to be Tuesday? Well, today's Tuesday. That's not going to change 3. 3 just stays 3. So the answer is just 3. And yes, those of you that know the shortcut, you would have just said, yeah, the answer is 3. As we go straight from here to here on this Friday's test, you're probably going to get a 0. Okay, you can't use that until exam number 3. Okay. All right, so that's that for now. Okay, now I'm going to do a little bit more in terms of graphs and some funny language. Okay, on page 155. Differentiable. Big word. Differentiable means you can take a derivative. Okay? So technically, you don't say a function is derivable. We say it's differentiable. I don't think you have to write it down, but that's the proper adjective for a function. We have a differentiable function if the derivative exists. Okay? And the verb form is to differentiate a function. So very technically, you don't say you derive a function, okay? Because there's another meaning for derive. So we say we differentiate a function, even though there's an English word differentiate also. But the verb form is differentiate. Okay? And even bigger word, differentiable. We can talk about a differentiable function. This is on the bottom of page 155. And now other notation for derivative. There's a lot of ways you can write derivative. Okay. The one that we have so far is f prime of x. We also have this one. Can you guess how you would say that? Y prime. Which makes sense, y prime. The only other one that we're going to use a lot is this one. It looks like dy over dx, but we will just say dy dx. Okay. And I would say don't even look at the others. We don't use it that much, so forget about these. The three big ones that we're going to use are f prime of x, f apostrophe x, y prime, y with the apostrophe, and this one that looks like dy over dx, but we're just going to say dy dx. Yeah, that looks like the most complicated of the three, but there's going to be good reason to use this notation a little bit later. Okay, maybe suffice to say, you've already seen delta y over delta x, right? Delta means change, and delta starts with the letter d in English, I guess, right? So instead of delta y over delta x, dy dx. So you don't have to say dy over dx, just dy dx. And this is all one symbol for derivative. It's one symbol, so don't like cancel out the d's or anything like that. It's one symbol for derivative. Okay. How can a function fail to be differentiable? Okay, so remember, differentiable, I can draw a slope. Okay, if there's a slope of a tangent line, is one of the interpretations. Okay, so one result, page 156. The function is differentiable at a point A, then f is continuous. So if we have a differentiable function at a certain point, it's also continuous. That makes perfectly good sense. If I were to just draw a graph randomly, so make a graph like this. Okay, so let's say at this point right here, can I draw a tangent line? Sure, let's go like that. So that means it's differentiable. It's automatically continuous. Okay, so sometimes the fancy language that we say is differentiability implies continuity. Don't even write that down. Okay, but if you have a differentiable function, it's automatically continuous. Differentiability implies continuity. If you have a differentiable function, if you can draw a tangent line, it's automatically continuous. Okay, but are there situations where a function is not differentiable? Okay, so on the next page, okay, take a look at this point right over here. Okay, they call this a vertical tangent line. What's the slope of a vertical line? Slope of a vertical line is undefined. Okay, so there's no such thing as a slope. So there's a case where the derivative will not exist. Take a look at this. They call this a corner point. Looks like a corner point. Now the function's still continuous, but you don't have any one slope at that given point. Okay, if I were to come from the left, I would say, well, the slope is something like this, right? But if I were coming from the right side, I would say the slope is something like that. So I don't have any one number that I could say is the slope. It's almost like I have two slopes, one coming from the left and one coming from the right. Okay, so here's a picture of a point where the function's continuous at x equals a. It's continuous, but not differentiable. Okay, so you can have continuity without differentiability. Okay, fancy words there again. Okay, so if you have a differentiable function, it's automatically continuous at a point, but not the other way around. Okay, here's a case where the function is continuous, but not differentiable. You have a corner point. Okay, and you can also have a discontinuity. Okay, so if the function is not continuous, it's automatically not differentiable. Okay. Here, you can talk about a tangent to the curve, right? It's going like this, but the tangent is vertical. So just because we have a vertical line, and what's the slope of a vertical line? It's undefined. So here's a case again where we would say the derivative does not exist. Okay, so where is a function not differentiable? If you have a corner point, a point of discontinuity, or a vertical tangent line. Okay, so vertical tangent line, you still do have a tangent line. Okay, but what's the slope? Well, it's undefined. Okay, I'll just digress a little bit. One way you can think about it is on a ride, like a roller coaster ride. If you think of a roller coaster ride or driving along the road, okay, except for this case, so ignore this case right now. These two are what I would consider dangerous points on a graph or a road. Okay, so if you show me a roller coaster that looks like this, I don't know about you, but I'm not going on that roller coaster, right? It just doesn't look right. I don't think you look at that and say, I'm not getting on that. That doesn't look right. And I'm not getting on that roller coaster either, right? It doesn't look like it's anything good's going to happen out of that, right? It looks like you're just going to fall off, come down to here or whatever, right? It doesn't look right. This one, it's okay. I've seen rides that are like that. Okay. The only thing about this one is you have a vertical tangent. So very, very technically, there is a tangent, okay, but it's vertical. So because of that, we're going to say that it's not differentiable there. So now there were some problems from section 8 at the very end. So yeah, I'm jumping out of order here. But give the reasons where the function's not differentiable at certain points. Okay, so 41 to 40, so I'm jumping way to 41 to 44 of 2.8. So let me knock those out of the way. Okay, the end of 2.8. And do I have time? Yeah, we might as well knock them all off. Okay, state with reasons the numbers at which the function is not differentiable. Okay, so we're either going to have a corner point like this, or a point where the function is not continuous, or a vertical tangent line. Okay. So 41. So where is the function not differentiable? Okay, so right here. So where's here? Negative 1, 2, 3, 4. So 41, put down negative 4. The reason is a corner point. Okay, so for 41, put x equals negative 4, corner point. And x equals 0. So what's happening at x equals 0? The function is not continuous. And let's see, I think that's about it. I don't think they intended that to be a vertical tangent. So that's fine. All right, so just x equals negative 4 and x equals 0. Not differentiable, not differentiable. Okay, how about 42? Okay, 42. All right, they have an, I'm not sure if you can see it, but there's an open circle here and then a dot right up here. Okay, so at x equals negative 1, not differentiable. And the reason is not continuous. By the way, let's abbreviate. Differentiable, you can put diff, D-I-F-F. So you don't have to write D-I-F-F-E-R-E-N-T-I-A-B-L-E. So differentiable, let's just put diff, D-I-F-F. Continuity, let's just put C-O-N-T, cont, for continuous or continuity, anything on that. Okay, so x equals negative 1, not continuous. And where else? X equals 2. So what happens at x equals 2? Sort of like over here, corner point, right? It's continuous, but you don't have any one slope. You do have a slope coming from the left, and it's not the same as the slope coming from the right. My hands are in the way. But okay, the slope over here looks like it's positive something. Slope over here looks like it's negative. Okay, 43. That looks like a closed dot, so we do have something over there. Okay, but that looks like another corner point. So let's say x equals 1, corner point. Okay, we're asking for the points where the function is not differentiable. Okay. Everywhere else the function is differentiable. So for 41, the function is differentiable right here and right here. Most of the time the graph is differentiable. Right? I can draw a tangent line here and here and here and here and here and so on. Okay. So 43 not differentiable at 1. Yeah, maybe they have bad aim, but let's say x equals 5 is a vertical tangent. Okay. If I give you anything like this on a test, I would have to make it very clear that it's meant to be a vertical tangent. So let's say x equals 5 is meant to be a vertical tangent. And I think that's about it. Everywhere else, I can talk about a slope, right? So there's a slope there, there's a tangent line there, and there, and there, and there, and there, and there. Yes, there's a tangent line at 5, but it looks like it's vertical. Okay, finally 44. So where's the function not differentiable? Well, at negative 2. So what's happening at negative 2? Corner point. And then at x equals 1, discontinuous, not continuous. And then at x equals 3, what's happening at x equals 3? Corner point, right? So at a corner point, you sort of have an abrupt change in direction. You very quickly move to a different direction. All right. Okay, so that's it for that one. Now, go back and do some more derivatives. 2.8, let me do 31. F of x equals x to the fourth. Find the derivative of the function. Okay. For these problems, let's take off the state the domain of the function, the domain of the derivative. Okay, so for the directions for 21 to 31 on 2.8, let's ignore state the domain stuff. So just find a derivative. Okay, so x to the fourth. Okay, and yes, you shortcut people, you really want to use a shortcut for this one. Sorry, you can't use it. Find the derivative of x to the fourth. Okay, so f prime of x, limit h approaches 0, x plus h to the fourth minus x to the fourth all over h. Okay, so you have to come up with x plus h to the fourth. So let me take a quick time out about that. What time is it? Okay, we have maybe 5 minutes left. Okay, so I wasn't really going to show you the whole thing. Just set you up with x plus h to the fourth. So there's a couple of things you could do. So this is a little timeout. X plus h to the fourth. Yes, we know it's x plus h, x plus h, x plus h, x plus h. That takes a while. You could do this. It's x plus h squared, x plus h squared, right? And you know each of these, x squared plus 2xh plus h squared times itself, right? And then you can multiply it all out. So that would work. You can go like that, x squared times that, and that, and that, and then 2xh times that, and then h squared times that. All of that would also work. I'll show you one more way. You may have heard of this before, maybe in pre-calc. Okay, if you've heard of Pascal's triangle. Pascal's triangle is very fast. And you say, what is Pascal's triangle? So I'm going to put a 1, and if you're copying what I have, put it in the middle of your paper. Don't put it way off to the left. Don't put it way off to the right. 1's going to be in the middle. Then I'll put 1, 1, like that. Not very interesting so far. Now, when I keep going down the triangle, the outsides are always 1. And then for anything on the inside, you add the 2 numbers directly above it. So that means you go 1 and 1 is 2. The next level, put a 1 here and a 1 here. Add these 2 numbers. 1 plus 2 is 3. 2 plus 1 is 3. So I have 1, 3, 3, 1. And just keep doing that. 1 goes here. 1 goes here. Add these 2. 1 plus 3 is 4. Add these 2. 3 plus 3 is 6. 3 plus 1 is 4. And then you have 1. And you can keep going. It turns out these will be the coefficients on the expansion right here. Okay, so this would have been, let's say, a plus b to the 0, a plus b to the 1, a plus b squared, a plus b cubed, a plus b to the fourth, and so on. So when I expand a plus b to the fourth, all you would have to do is go like this. A to the fourth, a cubed b. So what you do is you decrease the exponent of a by 1 and increase the exponent of b by 1. A squared, b squared, ab cubed, b to the fourth. So b goes 0, 1, 2, 3, 4. A goes 4, 3, 2, 1, 0. Plus, plus, plus. And the coefficients, believe it or not, are 1, 4, 6, 4, 1. 1, 4, 6, 4, 1, like that. And if you want to use this on the test, I'll let you. Okay, but that would be a shortcut. And you get that same thing if you bother to multiply all that in the cell. Okay, so using that, I've got this. So x plus h to the fourth, I quickly put x to the fourth, 4x cubed, 6x squared, h squared, 4x h cubed, h to the fourth. Okay, using that root. So the coefficients are 1, 4, 6, 4, 1, 1, 4, 6, 4, 1, x to the 4, 3, 2, 1, 0, h to the 0, 1, 2, 3, 4. And then minus x to the fourth all over h. Okay, x to the fourth cancels out. So that one, that one, that one, and that one have a common factor of 8. So same thing, factor out to h parentheses, 4x cubed plus 6x squared h plus 4x h squared plus h cubed all over h. These guys cancel out. Keep writing lim, limit h equals to 0. Okay, here's my expression, 4x cubed plus 6x squared h plus 4x h squared plus h cubed. Now I plug in 0. Okay, so 0, everywhere you see h, 0, so that's 0, that's 0, that's 0. So final answer, 4x cubed plus 0 plus 0 plus 0, 4x cubed. Okay, and for those of you that know the shortcut, yes, you know, that does work. Okay, but again, don't do that now. You have to show me all of this stuff on this week's exam. Okay, so I see we're just about out of time. I'm sorry, I didn't leave you any time for any questions or answers, but that's pretty much about it. See if I have something quick. You can always ask Prasanna during the class time for that. Okay, let me see if there's anything from the chat. Let's see. What does 1 over h do? 1 over h is the same as dividing by h. There were some problems where you had to divide by h, right? Sometimes it's better to multiply by 1 over h. Okay, and let's see. Prasanna, you got that? I canceled that. Okay, thank you, Prasanna. We got that. And I think that's pretty much about it. And it's just about 1 o'clock. Okay, so I think we're done, folks. So that'll be it for today. And have a good afternoon. And we'll continue tomorrow. All right, bye, everybody. Have a good day. See ya.
Bye.
Thank you.